In the late 1950s, the jet age was supposed to solve everything. Airlines had the Boeing 707 and the Douglas DC-8. Fast, powerful, long-range machines that were changing air travel forever. But there was a problem, a serious one, and it had nothing to do with the aircraft themselves. It had to do with where they could fly. Thousands of smaller American cities had airports, but those airports had short runways, no jet infrastructure, and sat far from the nearest major hub. The shiny new jets couldn't use them, and so millions of potential passengers were simply left out. Airlines wanted to connect those cities. They needed an aircraft that could land on a short runway, fly into an airport with minimal ground equipment, and still carry enough passengers to turn a profit. No such aircraft existed. Not yet. What Boeing built to solve that problem became one of the most successful commercial jets in history. And the story of how they built it is a story of impossible demands, engineering creativity, and a series of compromises that somehow produced something close to perfect. This is the Boeing 727. By 1956, Boeing was riding high on the 707, but the airline industry's appetite was more complicated than a single aircraft could satisfy. Three carriers, United Airlines, American Airlines, and Eastern Airlines, each had a vision for what their next aircraft should look like. And those visions did not agree. United wanted a jet that could serve its transcontinental routes and handle the thinner domestic legs efficiently. American had similar thoughts. But Eastern Airlines had a very specific constraint that would shape the entire project. Eastern operated out of New York's LaGuardia Airport, which had, and still has, notoriously short runways. They needed a jet that could get in and out of LaGuardia without a problem. But Eastern had another concern that came straight from the rulebook. At the time, federal regulations enforced what was called the 60-minute rule. Twin-engine jets were not permitted to fly routes that took them more than 60 minutes from a diversion airport. The reasoning was simple. If one engine failed, the aircraft had to be able to reach safety within an hour on the remaining engine. For Eastern's routes along the US East Coast, including over water legs to cities in the Caribbean, a twin-engine jet was a regulatory problem. Eastern wanted 3 engines. United, focused on longer overland routes, didn't share that concern. They wanted a twin. Boeing had to find a way to satisfy both without building 2 different aircraft. The 727 program was formally launched in 1960, and Boeing's engineers faced a design brief that would have made most people give up. The aircraft had to carry around 100 to 130 passengers. It had to operate from short, sometimes unpaved or lightly paved runways. It had to be capable of flying into airports with no jet bridge, no sophisticated ground equipment, which meant the aircraft needed its own built-in air stair. It had to have 3 engines to satisfy Eastern, and it had to cruise at speeds comparable to the 707 to keep it commercially competitive. Each one of those requirements, taken alone, was manageable. Together, they were a contradiction. 3 engines on a narrow-body jet raised an immediate question. Where do you put them? The obvious answer, one under each wing and one on the tail, had already been explored. But Boeing's engineers had a different idea, and it would define the look of the 727 for decades. Boeing put all 3 engines at the back of the aircraft, 2 in pods mounted to the rear fuselage on either side, and 1 buried inside the tail itself, fed by an S-shaped intake duct running from the base of the vertical stabilizer down to the engine. That S-duct, as it became known, was an engineering challenge on its own. Air doesn't like being bent. An S-shaped duct creates turbulence and uneven airflow, which hurts engine efficiency and can cause compressor stalls. Boeing's engineers spent considerable time refining the inlet geometry to make it work well enough. But putting all 3 engines at the back had a clear payoff. The wings were clean. No engine pods hanging under the wings meant the wing could be optimized entirely for aerodynamic performance. And that clean wing was exactly what Boeing needed to solve the short field problem. The 727's wing is where the serious engineering lives. And it's worth spending time here because what Boeing designed was extraordinary for its era. Getting a fast jet to operate from short runways requires generating a very high lift coefficient at low speeds. The kind of lift that lets you touch down slowly and stop in a short distance, or rotate and climb steeply on takeoff. The standard tools for this are high lift devices, slats and flaps that increase the wing's camber and effective area. The 727's wing used all of them. At the front of the wing, Boeing fitted a combination of Kruger flaps along the inboard section and leading-edge slats along the outboard section. When deployed, these devices extended the wing's leading edge forward and downward, increasing its curvature and generating more lift at low speeds. At the rear of the wing, Boeing went further. The 727 used triple-slotted Fowler flaps, one of the most complex high-lift systems ever fitted to a commercial aircraft at that time. A triple-slotted flap doesn't just deflect downward, it extends rearward, increasing the wing's chord, its front-to-back depth, and it creates two additional slots as it does so. Air from beneath the wing accelerates through those slots and re-energizes the airflow over the flap surface, preventing the flow from separating and stalling. The result is a dramatic increase in lift coefficient. When fully extended, the 727's Fowler flaps increased the effective wing area by roughly a fifth, while dramatically raising the wing's maximum lift coefficient. The aircraft could approach at speeds low enough for short-field operations, then fold everything away and cruise efficiently at 35,000 feet. This combination, a clean, high-speed wing with deployable high-lift surfaces, gave the 727 a performance envelope that no comparable aircraft could match. It could operate from runways barely 5,000 feet long. It served airports that jets had never seen before. Boeing also took the no ground equipment requirement seriously. The 727 was designed to be, as much as possible, self-contained. It had an onboard auxiliary power unit, an APU, that could provide electrical power and air conditioning on the ground without connection to external equipment. It had its own built-in air stair at the rear of the aircraft, folding down from beneath the tail so passengers could board directly from the tarmac. No jet bridge needed, no external stairs. That rear air stair would later make the 727 famous, for a reason nobody at Boeing anticipated. On November 24, 1971, a man using the name Dan Cooper, later misidentified in press reports as D.B. Cooper, boarded a Northwest Orient 727 in Portland, Oregon. He claimed to have a bomb, extorted $200,000 in ransom, had the aircraft land in Seattle to release the passengers, then ordered it to take off again, heading for Mexico. Somewhere over the southern Washington wilderness, at an altitude of around 10,000 feet, Cooper lowered the 727's rear air stair, while the aircraft was in flight, and jumped. He was never found. The money was never fully recovered. The case remains the only unsolved commercial aircraft hijacking in American history. Boeing's response was practical. They developed a device, quickly named the Cooper vane by the aviation world, a small aerodynamic flap fitted to the rear of the air stair. When the aircraft is airborne and airspeed exceeds a certain threshold, aerodynamic pressure forces the vane closed, preventing the air stair from being lowered. It couldn't be overridden from inside the cabin. The Cooper vane became standard equipment on all 727s. The 727 entered service with Eastern Airlines on February 1, 1964, with United and American following shortly after their own deliveries later that year. The aircraft was a hit almost immediately. It did exactly what Boeing had promised. It flew into airports that the 707 couldn't touch. It turned around quickly. It was efficient on short to medium routes. Airlines ordered it in large numbers. Boeing produced the original 727-100 in relatively short order, then developed the stretched 727-200, which added about 20 feet to the fuselage and increased passenger capacity to around 189 in a high-density configuration. The 727-200 became by far the more popular variant. By the time production ended in 1984, Boeing had built 1,831 727s. It was, at the time, the best-selling commercial jet in history. The aircraft served carriers across the world, not just in North America, but in South America, Europe, Asia, and Africa. It opened up city pairs that had never seen jet service. It was the workhorse of short and medium-haul aviation for the better part of 2 decades. Pilots who flew the 727 tend to describe it in terms that suggest the aircraft had a personality. It was fast, it was loud. The 3 rear-mounted engines gave the fuselage a constant vibration that passengers and crew could feel. The cockpit required 3 crew, a captain, first officer, and flight engineer, because the aircraft systems were complex enough to demand a dedicated systems manager. The 727 had handling quirks that demanded respect. The T-tail configuration, with the horizontal stabilizer mounted at the top of the vertical fin, made the aircraft susceptible to a phenomenon called a deep stall. In a deep stall, the wing's disturbed airflow blankets the tail, rendering the elevators ineffective. Recovery becomes nearly impossible. The 727's flight manual had specific procedures to avoid the conditions that led there, and pilots trained extensively on the aircraft's limits. It was not a forgiving aircraft if you pushed it too far, but pilots who mastered it often say it was one of the most satisfying jets they flew. It had a directness, a responsiveness that more automated modern aircraft don't replicate. The 727's dominance couldn't last forever. The fuel crises of the 1970s changed the economics of aviation. 3 engines burning fuel on routes that newer aircraft could fly on too was a cost airlines increasingly couldn't ignore. The Boeing 737, already in service since 1968, was cheaper to operate on shorter routes. The 757, which entered service in 1983, offered comparable capacity on 2 engines with significantly lower fuel burn and only required 2 pilots. Through the 1980s and into the 1990s, major airlines retired their 727 fleets. The passenger aircraft were sold off, converted to freighters, or scrapped. The freighter conversions extended the type's life considerably. A 727 with its rear air stair removed and a cargo door installed proved to be an economical package freighter, and hundreds continued operating in that role well into the 2000s. Major airlines retired their 727 fleets by the early 2000s, but in Iran, the type lingered much longer. Iranian carriers kept aging 727s flying well past the point where Western operators had moved on, a direct result of the sanctions that prevented them from acquiring newer Western aircraft. Iran Asman Airlines operated the last scheduled passenger 727 flight in January 2019, a service from Zaidan to Tehran, after which the type remained only in cargo, charter, or special roles. The 727 didn't survive by being the easiest aircraft to operate, the cheapest to maintain, or the most fuel efficient. It survived as long as it did because it could do things other aircraft couldn't. It opened up the jet age to cities and airports that would otherwise have waited years longer. It showed that the constraints imposed by regulators, geography, and competing airline demands could produce something more interesting than a straightforward design. Every compromise that went into the 727, the rear engine cluster, the complex wing, the built-in air stair, came from a specific problem that needed solving. And those solutions, taken together, produced an aircraft with a character unlike anything before or after it. Boeing built 1,831 of them. Airlines flew them on 6 continents. A hijacker jumped out of one and was never found. And engineers still study the 727's wing as a case study in high-lift design. Not bad for an aircraft born out of a committee that couldn't agree on how many engines it should have.